Hello, cosmic explorers. Today, we are about to embark on an extraordinary journey to the icy fringes of our solar system. Our destination, a controversial world that has challenged our definitions of what a planet is and has captured our imagination for nearly a century. Pluto. Imagine a place so cold that nitrogen forms glaciers, where mountains of water ice float in frozen nitrogen oceans, and where the sky takes on a soft blue hue. Welcome to Pluto, a world that, despite losing its status as a planet, has not lost any of its mystery and allure. Get ready to discover why this small, icy giant continues to astonish even the most seasoned scientists. If the idea of nitrogen glaciers and floating ice mountains has sparked your imagination, please give this video a thumbs up. And don't forget to subscribe to the channel, Exploring the Universe, for more incredible journeys through the wonders of our solar system. Pluto was discovered on February 18, 1930, by American astronomer Clyde Tombaugh at the Lowell Observatory in Arizona. Tombaugh's discovery was the result of a meticulous search for a hypothesized ninth planet, often referred to as Planet X, which was believed to be influencing the orbits of the known planets. Using a method called blink comparison, Tombaugh compared photographic plates taken at different times to detect the movement of celestial bodies against the static backdrop of stars. Interestingly, Pluto holds the distinction of being the only planet discovered by an American. This achievement was pivotal, as it marked a significant contribution to astronomy during a time when the field was dominated by European discoveries. The planet was named by Venetia Burney, an 11-year-old girl from Oxford, England. Venetia suggested the name Pluto after the Roman god of the underworld, reflecting the planet's dark and distant nature. Her suggestion was both poetic and fitting, capturing the imagination of the public and scientists alike. For 76 years, Pluto was considered the ninth planet of our solar system. During this time, it became a fixture in textbooks and a point of fascination for astronomers and the general public. However, Pluto's unique characteristics set it apart from the other planets. Its orbit is highly elliptical and significantly inclined compared to the orbits of the other planets. This means that Pluto's distance from the Sun varies dramatically over its 248-year orbital period, bringing it closer to the Sun than Neptune for a brief period. The search for Planet X played a crucial role in Pluto's discovery. Astronomers were looking for a large, undiscovered planet that they believed was affecting the orbits of Uranus and Neptune. When Pluto was found, it was initially thought to be the long-sought-after Planet X. However, as more observations were made, it became clear that Pluto was much smaller than expected, leading to further questions about its classification. Pluto's unique orbital dynamics and its relatively small size prompted ongoing debates within the astronomical community about its status. As more trans-Neptunian objects were discovered, it became increasingly apparent that Pluto was part of a larger population of icy bodies, leading to a re-evaluation of what constitutes a planet in our solar system. This set the stage for the eventual reclassification of Pluto, raising important questions about how we define celestial bodies and their place in the cosmos. In August 2006, the astronomical community witnessed a significant paradigm shift when Pluto was reclassified as a dwarf planet by the International Astronomical Union. This decision marked the end of Pluto's reign as the ninth planet of our solar system, a status it had held for over 76 years. The IAU's redefinition was based on three criteria that a celestial body must meet to be considered a planet. It must orbit the Sun, be spherical in shape due to its own gravity, and have cleared its orbit of other debris. Pluto failed to meet the third criterion, as it shares its orbital zone with other objects in the Kuiper Belt, a region beyond Neptune filled with numerous icy bodies. This reclassification sparked widespread controversy and debate among astronomers, planetary scientists, and the public. Many felt that the decision was arbitrary and overlooked Pluto's unique characteristics and historical significance. Some scientists argued that the definition of a planet should be broader and more inclusive, while others contended that a stricter definition was necessary for clarity in planetary science. This ongoing debate highlights the complexities of celestial classification and the evolving nature of our understanding of the universe. Pluto is a fascinating celestial body with physical characteristics that set it apart from the more familiar planets in our solar system. One of its most striking features is its size. Pluto is approximately 2/3 the diameter of Earth's moon. This relatively small size contributes to its classification as a dwarf planet. In terms of composition, Pluto is primarily made up of rock and ice, with a surface that features a diverse array of geological formations. Recent data from NASA's New Horizons mission suggests that Pluto may have a subsurface ocean of liquid water beneath its icy crust, which could have significant implications for our understanding of its geology and potential for harboring life. Pluto's atmosphere is another intriguing aspect of this distant world. It is thin and primarily composed of nitrogen, with traces of methane and carbon monoxide. This atmosphere undergoes significant changes as Pluto moves closer to or farther from the Sun during its elliptical orbit. When Pluto is closer to the Sun, the heat causes the atmospheric pressure to increase, leading to the expansion of the atmosphere. Conversely, as Pluto moves away from the Sun, the atmosphere contracts, creating a dynamic and ever-changing environment. These characteristics not only make Pluto a unique subject of study, but also highlight the complexities of celestial bodies in our solar system. Pluto's most significant moon is Charon, which is an intriguing celestial companion. Charon is almost half the size of Pluto itself, making it one of the largest moons relative to the size of its planet in the solar system. This size ratio leads to fascinating dynamics between the two bodies, as they are often described as a binary system. In a binary system, both celestial bodies orbit around a common center of mass, known as the barycenter. For Pluto and Charon, this barycenter is located outside of Pluto's surface, which means that both bodies effectively dance around this point in space. This unique relationship leads to a captivating visual effect in which Charon appears to be locked in a synchronous orbit with Pluto, always showing the same face to its planet. This dynamic creates a distinct gravitational interplay, influencing both bodies' shapes and orbits. In addition to Charon, Pluto has 4 other known moons: Nix, Hydra, Kerberos, and Styx. Nix and Hydra were discovered in 2005, while Kerberos and Styx were found during the New Horizons mission. These smaller moons are irregularly shaped and much less massive than Charon, contributing to the complexity of the Pluto system. The interactions among these moons and Pluto provide astronomers with valuable insights into the history and evolution of this distant region of our solar system. The Pluto-Charon system, with its intriguing dynamics and diverse moons, exemplifies the complexity of celestial mechanics and showcases the continual discoveries being made in our exploration of the cosmos. If the idea of nitrogen glaciers and floating ice mountains has sparked your imagination, please give this video a thumbs up. And don't forget to subscribe for more incredible journeys through the worlds of our solar system. Launched in 2006, NASA's New Horizons mission marked a significant milestone in our exploration of the solar system. After a nearly decade-long journey, the spacecraft made its historic flyby of Pluto on July 14, 2015. This mission was groundbreaking, as it was the first to provide detailed images and data about Pluto, revealing a wealth of information about this distant world. The images captured by New Horizons were stunning, showcasing Pluto's diverse and complex surface. Among the most notable discoveries was the feature known as the Heart of Pluto, a large heart-shaped region called Tombaugh Regio. This area features vast plains of frozen nitrogen interspersed with intriguing geological formations. The mission also revealed towering mountains of water ice, some reaching heights comparable to the Rocky Mountains on Earth. Perhaps most surprising were indications of possible cryovolcanoes, volcanoes that erupt icy materials instead of molten rock. These findings suggest that Pluto may still be geologically active, challenging previous assumptions about its age and evolution. The data collected by New Horizons has not only transformed our understanding of Pluto, but has also opened up new questions about the potential for similar processes on other icy bodies in the solar system. Pluto's geology is as fascinating as its atmosphere and moons. One of the mission's standout features is Sputnik Planitia, a vast plain of frozen nitrogen shaped like a heart. This region is characterized by its smooth, featureless surface, suggesting a relatively young geological age. The presence of nitrogen ice indicates that there are complex processes at play, possibly involving the movement and redistribution of surface materials. Adding to the intrigue are the water ice mountains, which appear to float on the nitrogen ice. These mountains, rising as high as 3,500 meters, are composed primarily of water ice, which is less dense than the surrounding nitrogen. This unique combination of materials and geological processes suggests that Pluto's surface is actively changing, driven by internal heat and possibly subsurface ocean activity. The evidence of active geological processes, including cryovolcanism, points to a dynamic environment that challenges our understanding of what constitutes geological activity. The possibility of liquid water existing beneath the surface opens the door to discussions about the potential for life in extreme environments, not just on Pluto, but across other icy bodies in the Kuiper Belt and beyond. In summary, the New Horizons mission has revolutionized our understanding of Pluto, revealing a world of unexpected complexity and beauty, and inviting us to rethink our assumptions about what lies beyond the familiar planets of our solar system. Pluto's atmosphere is a fascinating aspect of this distant world, primarily composed of nitrogen, with trace amounts of methane and carbon monoxide. This thin atmosphere is not only intriguing due to its composition, but also because it exhibits dynamic behavior influenced by Pluto's elliptical orbit around the Sun. During its closest approach to the Sun, the heat causes the atmospheric pressure to increase significantly, leading to the sublimation of surface nitrogen ice into gas. Conversely, as Pluto moves further away from the Sun, the atmosphere contracts and some gases may freeze back onto the surface. This cycle of expansion and contraction results in seasonal changes that affect the atmosphere's density and composition. A striking feature of Pluto's atmosphere is the presence of bluish haze layers detected by the New Horizons mission. These haze layers are thought to be composed of complex organic molecules called tholins, which are created when ultraviolet light from the Sun interacts with methane and nitrogen in the atmosphere. This process results in a layered, hazy appearance, giving Pluto a unique atmospheric profile. The varying thickness of these haze layers and their distribution around the planet provide insights into atmospheric dynamics and the interactions between surface and atmospheric processes. The Kuiper Belt is a vast region of the solar system that extends beyond Neptune's orbit, populated with numerous icy bodies, including dwarf planets, comets, and asteroids. Pluto is one of the most famous objects in this region, and its study has greatly contributed to our understanding of the Kuiper Belt's formation and evolution. The Kuiper Belt is thought to be a remnant from the early solar system, containing materials that never coalesced into planets. This region plays a crucial role in understanding the dynamics of the outer solar system and provides a glimpse into the conditions that existed during its formation. Other notable objects in the Kuiper Belt include Eris, Makemake, and Haumea, each of which offers unique characteristics and insights into the diversity of icy bodies in this distant region. Pluto's significance extends beyond its own characteristics. Studying it helps astronomers piece together the history of the outer solar system, its interactions with other Kuiper Belt objects, and the insights gained from missions like New Horizons challenge our understanding of planetary formation and the processes that govern celestial dynamics. Pluto serves as a key to unlock the mysteries of the Kuiper Belt and to better comprehend the evolution of our solar system as a whole. The classification of Pluto as a dwarf planet has sparked an enduring debate within the astronomical community and among the public at large. Proponents of Pluto's reclassification argue that it failed to meet the criteria set forth by the International Astronomical Union in 2006, specifically the requirement that a planet must clear its orbital neighborhood of other debris. They contend that Pluto shares its orbit with numerous other objects in the Kuiper Belt, which justifies its status as a dwarf planet. Conversely, many scientists and planetary advocates argue that the definition of a planet should be more inclusive. They emphasize that Pluto possesses several characteristics commonly associated with planets, including a spherical shape, a complex atmosphere, and geological activity. Supporters of Pluto's planetary status often cite its rich history and cultural significance, arguing that it should not be dismissed simply because it does not fit neatly into a rigid classification system. The concept of dwarf planet, while scientifically valid, has also been deemed problematic by some. Critics argue that it creates a new category that lacks clear boundaries and may lead to confusion. For instance, if Pluto is classified as a dwarf planet, what does that mean for other similar bodies in the Kuiper Belt and beyond? This ambiguity raises questions about the criteria used to define celestial bodies and whether they adequately reflect the diversity of objects in our solar system. The I Love Pluto campaign has emerged as a grassroots movement aimed at advocating for Pluto's reinstatement as a planet. This campaign highlights the emotional connection people have with Pluto, emphasizing its role in popular culture and education. By rallying public support, advocates have sought to remind the scientific community of the importance of Pluto not just as a celestial object, but as a symbol of exploration and discovery. This emotional appeal underscores how scientific classifications can intersect with human curiosity and imagination. In summary, the debate over Pluto's status encapsulates broader questions about how we categorize celestial bodies and the implications of those classifications. As our understanding of the solar system continues to evolve, so too will the discussions surrounding Pluto and its place among the planets. Whether as a dwarf planet or a beloved former planet, Pluto remains an object of fascination that invites us to explore the complexities of our universe. In conclusion, our journey through the fascinating world of Pluto has revealed a plethora of surprising discoveries that challenge our understanding of the solar system. From its complex atmosphere composed primarily of nitrogen to the stunning geological features captured by the New Horizons mission, Pluto has proven to be a dynamic and intriguing body. The presence of nitrogen glaciers, towering ice mountains, and even the possibility of cryovolcanoes highlight that Pluto is far more than just a frozen relic of the past. Despite its reclassification as a dwarf planet, Pluto continues to captivate both scientists and the public alike. Its rich history and unique characteristics evoke a sense of wonder and curiosity that transcends simple classification. The ongoing debates about its status reflect a broader fascination with the cosmos and our desire to explore and understand the universe around us. Pluto serves as a reminder that our knowledge is always evolving and that there is still much to learn about this icy giant and its place in the cosmos. As we look to the future, we can only imagine the possibilities that lie ahead. What new missions will venture to Pluto or other distant worlds? What further secrets might they unveil about the formation of our solar system and the potential for life beyond Earth? The exploration of Pluto and its surroundings promises to be an exciting frontier in planetary science, inviting us to continue our quest for knowledge. If this video has given you a new perspective on Pluto, please take a moment to like and subscribe to the channel, Exploring the Universe. Together, we will continue to explore the wonders of our solar system, proving that sometimes the smallest objects hold the greatest secrets.